Hi, my name is Arne Stannes and I am the author of the CHEMIX School software. In this tutorial I will show you how to balance chemical equations, not only by hand, but also by the use of CHEMIX School.
To use the chemical balancer, press the Balance button. Insert an unbalanced equation in the upper text field. To separate the reactants from the products, use the greater than sign, as a substitute of the normal arrow, as demonstrated here. To balance the inserted equation, press the Calculate button. The balanced equation will be displayed in the gray text field below the inserted equation. Moles and masses of products and reactants can be seen in the greater gray text field below the balanced equation. Matrix and calculated coefficients are located in the lower text field. To retrieve saved equations, tutorials, comments, and more, simply double-click one of the elements in the list box. To remove the content of the text fields, press the Clear button. The first equation is a simple one, the reaction between hydrogen and oxygen in the formation of water. In this equation the reactants are hydrogen and oxygen. Water is the product. To balance this equation we need to add variables in front of each compound, here illustrated by the three pointing arrows. In our first balance example where hydrogen and oxygen reacts to form water, start by adding variables in alphabetical order in front of each compound. We will now use the chemical equation to create a series of simultaneous equations, one for each element. First, we create an equation for hydrogen by counting hydrogen atoms in each compound. The hydrogen molecule consists of 2 hydrogen atoms. The water molecule also contains 2 hydrogen atoms. For hydrogen, the equation will be 2A equals 2C. Similarly, we do the same for oxygen. The oxygen molecule consists of 2 oxygen atoms but the water molecule only contains a single oxygen atom. For oxygen, the equation will be 2B equals C. We now have to calculate the coefficients with the help of our newly created equations. We need to give A and C integer values. By convention, these integer values have to be as low as possible. Since A equals C, we give both A and B the value 1. In the case of oxygen, since 2B equals C, C equals 1, and B equals a half. By convention, We don't want fractions in the balanced equation, and the integer solution should be as low as possible. To resolve the issue with the fraction, we have to multiply all the coefficients in the equation by 2. Now we have a correctly balanced equation by convention. To check the validity of our result, we can insert the unbalanced equation in CHEMIX School and compare the results. In this case, there is no difference between our manual calculation by hand and the computer calculation. To balance the combustion of methane, we use the same procedure as for the water example. The most significant difference between the previous example versus this example is that while the reaction between hydrogen and oxygen in the previous example only formed water, the combustion of methane forms two products, namely carbon dioxide and water. As we did in the last formation of water balance example, we start by adding variables in alphabetic order, in front of each compound. The compounds in the equation consist of a total of 3 elements, carbon, hydrogen, and oxygen. We will now use the balance equation to create 3 equations, one equation for each element. Carbon exists in both methane and carbon dioxide. It is the same amount of carbon atoms in both compounds, namely 1. The first equation will therefore be A equals C. There are 4 hydrogen atoms in each methane molecule and 2 in each water molecule. The hydrogen equation, 4A equals 2D. Oxygen is found once in the reactant side of the equation and twice on the product side. And the last oxygen equation, 2B equals 2C plus D. In the first equation, we assign A and C a value of 1. In the second equation we can calculate D, by replacing A, by a value of 1. D equals 2. By replacing C and D in the third equation by the numeric values of 1 and 2, we calculate that B equals 2. The last thing to do is to add the coefficients in front of each compound in the previous unbalanced equation. Since the equation now is in balance, remember to replace the arrow between reactants and products with a equals sign, as we did here. Again, to check the validity of our result, we can insert the unbalanced equation in CHEMIX School and compare the result. The fact that there is no difference between our manual calculation by hand and the computer calculation ensures us that it has been done correctly. The next example, involving the reaction between calcium carbonate and phosphoric acid, is only slightly more complicated than the previous methane example. Again, the first thing we do is to add variables in front of each compound in alphabetical order. This is an example of a reaction that involves a total of 5 elements. These elements are calcium, carbon, oxygen, hydrogen, and phosphorus. Calcium is represented in the first compound by 1 atom and by 3 atoms in the third compound. This translates to the equation, A equals 3C. Carbon is represented in the first and fourth compound by 1 atom. The equation for carbon is therefore, A equals D. Oxygen exists in all the compounds. Starting from the left, the compounds contain 3, 4, 8, and 3 oxygen atoms. The equation for oxygen is 3A plus 4B equals 8C plus 3D. Hydrogen exists in both the second and the fourth compound by 3 and 2 atoms respectively. This means that the equation for hydrogen must be 3B equals 2D. The last element, phosphorus, exists in both the second and the third compound by 1 atom and 3 atoms respectively. B equals 2, C. If we assign A with an integer value of 3, the equation tells us that the C value must be 1. It follows that D equals 3. To calculate B, we use the simplest of the 3 last equations containing the letter B, the other 2 is not needed. B equals 2. Now it's time to add the coefficients in front of each of the compounds. the absence of fractions, and that all the coefficients are the lowest integers possible, tells us that the equation has been balanced correctly according to the convention. Since there again is no difference between our manual calculation by hand, and the computer calculation, we can regard our answer as correct. It's just another CHEMIX School tutorial. Thank you for watching. Don't forget to subscribe.